Good morning, student. Now it is HS2ndyr Commerce CMST class. We have done up to the principle of mathematical induction. We have done some of this one also. Now again, one type of sum of this type we will do, and then we will go in next things. So exercise 2.2 2.3 we are doing, and it is overall of principle of mathematical induction. Here question number, suppose 6 we are going to do 1 by 1.3, 1 into 3, 3 into 5, 1 by 5 into 7 plus dot 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 1 by twice n minus 1 twice n plus 1 is equal to n by twice n plus 1. So here you see that how to do. Already we have done, same procedure we will follow. Let P inside bracket n do the statement. This is the way of writing. The statement's name you write. This is the statement. For n is equal to 1, if we put n is equal to 1, LHS, it is 1, 1.3, that is what? 1 by 3. RHS is what? It is 1, if we put 1, 2 into 1 plus 1. What we have done? We have replaced n by 1. So automatically it is 1 by 2, 1 that 2 plus 1, that is 3. So LHS is equal to RHS, implies P inside bracket 1 is 2. So student, it is the way of writing, way of doing these things. Let P inside bracket K be true. Yes, if we replace n by k, then our answer will be 1 by 1.3, 1 into 3, 3 into 5. In this way, last term is twice k minus 1, twice k plus 1 is equal to k by twice k plus 1. Now students, P inside bracket k we have taken, suppose it is true, and target is to prove that pk plus 1 is true. So this means if we add here twice k minus 1, twice k plus 1, I want to add a new term. This suppose n is equal to k plus 1. So here what we are going to add, that is 2 inside bracket k plus 1 minus 1. This is 1. Another is 2 inside bracket k plus 1 plus 1. So students, what we have done, up to k, this line it was. Now I have added a new term of k plus 1. Now this term is what? K by twice k plus 1. Here, if we withdraw this bracket, twice k plus 2 minus 1, it will be twice k minus 1. And not minus 1, plus 1. And this is twice k plus 2 plus 1, that is 3. If I take LCM, this is common term, so automatically twice k plus 1, twice k plus 3, and here k into this, that is twice k square plus thrice k plus 1 it will be. Then if we want to do the simplification of this one, then we will get twice k plus 1, twice k plus twice k square plus twice k plus k plus 1 divided by twice k plus 1 into twice k plus 3. After taking common from these two, it will be twice k plus 1, and here k plus 1. So ultimately we get this term. Now remaining part gives a long sum. So from here, if we take k plus 1 common, inside bracket twice k plus 1, there it is twice k plus 1 into twice k plus 3. So we can cancel these two. So what we have achieved, that k plus 1 twice k plus 1 plus 1. Shall I write? See that you can write like that. That means what? Pk plus 1 is true if P inside bracket k is true. So from 1 and 2, 1 what it was, P1 is 2, from 1 and 2, by principle of mathematical induction, P inside bracket n is true. So students, big answer it is, and remember, yes, if you do this sum, more than 4 marks is there. So definitely you have to practice this one. So with that we have finished the question number 2, this type of sum. Now we will do question number 3. 3 is of little bit different type, but method is same like that. They have asked to prove question number 3.1 that prove that 5 to the power twice n plus minus 1 is divisible by 9. So student, how to do this one? Procedure is same. Let P inside bracket n be statement. What statement? That this is divisible by 9 statement. For n is equal to 1, if we put n is equal to 1, this term will be what? 5 to the power 2 into 1 plus 3 into 1 minus 1. 5 square, that is 25, plus 3 minus 1, that is 27, which is divisible by, definitely 27 is divisible by 9. Therefore, P inside bracket 1 is 2. Let 5 to the power twice k plus 3 to the power k minus 1 is divisible by 9. Yes, this term is divisible by 9. So what we can write implies 5 to the power twice k, 3 to the power k minus 1 is equal to 9 into, suppose one integer is a, where a is an integer. Yes, I have written this one. Now we will write, instead of n, we will put k plus 1. 5 to the power twice k plus 1, 3 k plus 1 minus 1. So we can write 5 to the power twice k into 5 square, thrice k plus 3 minus 1. This 5 to the power k will replace from this one. Here 5 to the power twice k will be what? 9a minus thrice k plus 1 will replace. Before that we will write 5 square is 25. So its value is 9a minus thrice k plus 1 plus thrice k plus 2. So what we get? 25 into 9. So better you write 9 into 25. Okay. Minus 3 into 25k plus 25 plus thrice k plus 2. Now, students, if we take these two thrice k common, what we get? 9 into the 25a. Here, thrice k if you take common, it will be 25 minus 1, that is 24. So 25 minus 1, okay, and this is 27. So little bit we have to clean. So from here we can write 9 into 25a minus thrice k into 24 plus 27, and we can take 9 common, 25a minus thrice k, here 3 into 8, so 9, so minus 8k plus 3, so 9 into something, so definitely which is divisible by. Now what we get, that pk plus 1 is true if pk is true. Therefore pk plus 1 is true if pk is true. It is our proof from 1 and 2 by principle of mathematical induction. Given statement is true. So students, you practice these things again and again. Of course, I think you will get. So give your attendance in your comment box. That much for today.